now we're going to be talking about something, not long division, but something called synthetic division. So synthetic division of polynomials will prove a little bit easier. For one, it's definitely easier to write because we don't have to write all the exponents and all the variables. We just have to write the numbers. But we can only use it in certain cases. If we divide a polynomial by something of the form x minus k. So if I'm just dividing a polynomial by x minus some number, then I can use synthetic division with a divisor of k. Now I'll explain what this means in a minute. The thing to notice here is I'm dividing by x minus a k, but when I do synthetic division, what do I do with my k? I switch the sign. So instead of a negative here, it's going to be a positive here. That's vastly important. Let's just look at an example, and we'll talk some more about that. Suppose that I have 6x squared, so we'll start off with example 1. 6x squared minus 29x minus 5 divided by x minus 5. So the first thing to notice is that I am dividing by, this is what I'm dividing by, and does it have the right form? Is it of the form x minus something? Yes. So it has the right form. So now I want to try to use synthetic division. Let me show you how to set up the synthetic division. So your divisor is going to be the opposite sign of this thing. So my divisor is going to be 5. Then I'm going to draw this little L-shaped box. Now I want to write the coefficients of all my powers of x here. So I'm going to have a 6, I'm going to have a negative 29, and I'm going to have a negative 5. Okay? Let me just kind of put some notes on here. So this is my divisor. This is a row of the coefficients of my polynomial. Okay. Step 1, just bring down the first number. Just bring down a 6. Bring down the first. Step 2, multiply this number, 6, and 5. So 6 times 5 is what? 30. Multiply 6 times 5 and put the product here underneath the next number. Now to continue on, you want to add the columns. So instead of subtracting, the way in long division, we're going to be adding. So what is negative 29 plus 30? 1. So we add these two, and now we just continue to repeat the process. 5 times 1 is what? 5. So we put that 5 there. Now we're going to add this column. What does this give us? 0. Okay. Now what in the heck do all those numbers actually mean though, right? Because we want to translate this back to polynomials. So what do these numbers mean? First of all, this number, the last number, is your remainder. So what does it mean if I have a remainder of 0? What do you say? No remainder. What does that mean? Like, think about going back to numbers. Whenever you divide a number by another number and you have a remainder of 0, what did that mean? So it's a whole number, right? So it divides evenly. So the number that you're dividing by is actually a factor, right? So that's your last number is your remainder. Now the other numbers, we have to translate those back to polynomials. Notice that I started with a quadratic polynomial, that is a polynomial with x squared. Okay? Now I'm dividing by an x, so that means my first number is going to be a coefficient of, well, what's x squared divided by x? X. So this translates to 6x plus, now what's my next, again it's going to be in descending order, what's my next power of x going to be? X to the 0, which means there's not going to be any x, right? X to the 0 is just 1, so it's just going to be plus 1. What's that? This is the answer. That's what this 6 and 1 means. 6x plus 1 with a remainder of 0. Okay, with a little practice, synthetic division might be a little bit easier. However, a couple of things you have to remember. One, that you have to remember to change the sign of this factor that you are dividing by. The other things you have to remember, you're adding. You have to remember the process, and you also have to remember how to translate it back to polynomials.